Hello everyone and welcome to MV Tutors. I'm Tulu and I'll be discussing circles in analytical geometry. Okay, it's not the Euclidean geometry circles, but the ones for analytical geometry. Alright, so before we go any further, please do not forget to like our videos as well as subscribe to our channel. And while you're at it, why don't you just click also on the notification bell so that whenever we upload any videos, you are the first to know. Okay, and if you'd like to book a session with us, please go to our website at www.mvtutors.co.za to book a lesson. And yeah, let's get started. So I thought I would do a little bit of a recap from grade 11 before we get into the meat of the session. Alright guys, so by now you should know the distance formula between 2 points. So let's say I have coordinate A and coordinate B. If I wanted the distance between A and B, okay, I would then take the difference of the x coordinates. If you're going to start with the coordinate of B, okay, so x2 is from B, please maintain that also when you get to the y coordinate, okay? Make sure it's the y coordinate of B. If you wanted to start with the x coordinate of A and you subtract the x coordinate of B, it's all cool, but make sure that the y coordinates also correspond to that. Don't decide to flip it because signs might be wrong or the numbers might just be wrong. So please just be consistent. Okay, so we get the difference of the x coordinates and we square them, and we do the very same thing for the y coordinates. And then after getting that answer, we root it, we square root it, and then we can get the distance between the 2 points, points A and B. If you wanted to get the gradient between A and B, well, basically we use the small letter m with the subscript AB, okay, and then we get y2 minus y1 over x2 minus x1, or you could say y1 minus y2 over x1 minus x2. But please, if you're going to start with y1, make sure even with the x, it's x1. Okay, be consistent. And basically the gradient is just the change in y over the change in x. That's pretty much that. Okay, see, now we get to look at the midpoint between points A and B, or whatever coordinates they have given you. And that would be the capital letter M with the subscripts A and B, depending on the points that you have. In this case, we're talking about A and B. And that will basically be the sum of your x coordinates over 2. And you have a semicolon here, okay? And then the sum of your y coordinates over 2. All right, so this is basically like getting the coordinates of your midpoint. All right, that is why you have a semicolon in between the x and the y. All right, so those are the midpoints. And this actually can come in handy when you're busy looking at circles as well. Remember when you have a circle, okay, you have your center there, right? Okay, so from a line passing the center, touching the circumference, that's basically your diameter. And if you wanted to get the midpoint of your diameter, okay, if you wanted to get the midpoint of your diameter, the coordinates over here, you can basically, well, depending on whether you have these coordinates, so if you have x and y here, and you have x and y there, you can definitely get what the center of your circle is if you have these points. Okay, you can use the midpoint between the points. Okay, midpoint formula basically to get the coordinates of your center. And then if you want to if you want to find the equation of a straight line, you need a point on a line and the gradient of the line. Okay, so what are you going to do with the point and a gradient? Well, basically, you're going to take the y coordinate of your point, substitute it there, the x coordinate of your point, substitute it right there, and then the gradient, substitute it there at m. Then you are solving for c. And once you have solved for c, you can write your equation of the line, which is y is equal to m, which you already have, x plus c, which you already solved. And that is how you get the equation of a straight line. And lastly, with the revision, If you want to get the inclination of a line, okay, that's basically going to be, you're going to use the equation tan theta is equal to m. Okay, so let me just pause a bit. There's like noise that's not finishing. All right, so when you have your Cartesian plane, okay, so you have your y and x axis, and then you have a line, straight line, okay, that has a positive gradient. Your angle of inclination will go anti-clockwise, okay. Even if you were to have a line this way with a negative gradient, your angle of inclination would be that way, okay. It would be that big. So if you're going to put a negative gradient in the calculator, well, it might give you a negative acute angle. The calculator might give you a value here which is negative. You just need to take 180, okay, and subtract the positive angle there so that you can get your theta. Okay, I hope I'm making sense, but basically that is how you get the inclination of a line. The equation being tan theta is equal to m, which is your gradient of your straight line. Okay, now we get to the circles. So what happens if you have a circle centered at the origin? Okay, if you have a circle centered at the origin, that's great. Your equation is not going to be complicated. Okay, it's going to be straightforward. Okay, so how do we actually derive the equation of a circle? You're definitely going to use the distance formula. Okay, so at the center of the circle where your coordinates are 0 and 0, you'll have your radius. Okay, the radius of a circle is always the same, so it doesn't matter whether you have a radius on the second quadrant or the first quadrant. You know, many of them, they're all going to be the same. Gonna get the same radius. All right, so now when you use the distance formula, you have your point at the center and a point somewhere on the circumference, and you're going to use the distance formula as you know it. So you're going to get the difference between the x coordinates as well as the y coordinates, and then you square them, and then the sum of them you are going to square root it. Okay, and then at the end you're going to find that actually the equation of a circle with a center at the origin and the radius r is actually equal to x squared plus y squared is equal to r squared. Guys, please don't forget this formula. It should be, probably is on the formula sheet, but if the circle is at the center, okay, or rather if the center of the circle is at the origin, yes, if the center of the circle is at the origin, the only thing that you really need is to get your radius, but your equation is going to be straightforward. It's just x squared plus y squared is equal to r squared. And if they ever asked you to actually show how you got to that, you can use the distance formula. Okay, now what if the circle is not centered at the origin? Well, it's not a train smash. This is what you would do. All right, so you have the center of your circle, which is somewhere not at the origin, so we're going to just use A and B. All right, and then again the radius will be the same regardless where you point at the circumference. Okay, so yeah, but let's just say we're looking at the radius with the point there being on the first quadrant, okay, where both x and y are positive. Well, we're still going to use the distance formula. Okay, so we know that the x coordinate of the center, that would be A, and the y coordinate at the center is B. Okay, and then our points there, we have x and y. We're still going to go ahead and use the distance formula. And once you're done with it, the equation of a circle with the center AB, coordinates AB, and radius r would be x minus a squared y minus b squared is equal to r squared. So if you already know what the center or the coordinates of the center are, you can substitute them in A and B. Okay, if your center has a negative, maybe let's say if we looked here, this would be positive A, but that would be negative B because y is negative in the fourth quadrant. So you would actually have y minus minus b, which would be y plus b. Okay, so just be aware of that. All right. But the formula is x minus a, all of that is squared. Then you have y minus b, and all of that is squared, and that will be equal to r squared. Alrighty. So now, in general, if you want to get the equation of a circle, the center and the radius must be known. You just need these two things, the center as well as the radius. Like I said, it's nice if your center is at the origin. That's sorted out. You can just get the radius. But if it's not at the origin, then you must get what the center is, and then you must get the radius, and then you can write down the equation of a circle. Now, sometimes the equation will not be put like this, okay? So you won't have here nicely put x minus a squared, y minus b squared is equal to r squared. Sometimes it is calculated out, okay? So it is given out in a multiplied form. So what are we going to do to get it back into the way we're used to it? Well, we're going to have to complete the square. Okay, I hope you haven't forgotten how you complete the square. Okay, so please, the one thing about maths is it is cumulative. What you've learned years before, you have to take with you to better understand the current year you're in. So please do not forget stuff in grade 10 and 11 and even way back. Okay, they come back. Trust me. So yeah, if you get it in a multiplied form, we're going to complete the squared. And the one thing about completing the square, okay, first of all, the coefficients of x and y, they must be the same. Okay, let's say you already have 2x squared, you must have 2y squared here, or else this will not work. And once they are the same, please make sure that before you even start completing the square, one of the rules is that you must only have one as a coefficient. Okay, so let's say you had that 2 for both x squared and y squared. You're going to have to divide everything else by 2 such that you are left with 1 as your coefficient. Okay, because now it will start getting tricky, or it won't work out if you're trying to complete the square when you still have coefficients that are not 1 for x squared and y squared. But anyway, let us try this example out. Let us complete the square. Let's see how it's done. Okay, so I'm going to focus on the x's alone and the y's alone, and yeah, we'll see how we do it. Okay, so we have x squared minus 2x. So what I do, I take the coefficient of x. Okay, so firstly I'm going to add it, and then in my brackets I'm going to have minus 2. Once I take the coefficient of x, I divide it by 2, and then I square. And because I added over here, I'm going to have to subtract over there. Same thing. Coefficient of x divided by 2, and then we square it. Then we get to the y's. So I have y squared plus 10y. Okay, I'm going to take the coefficient of y, which is positive 10, divided by 2, and then square it. And because I added over here, I'm going to have to subtract. Okay. And then again, coefficient of x divided by 2, we square it. And then all of that is equal to negative 17. So what do I do now? I'm going to take this portion here. Okay, put it in brackets. I'm also going to take this portion here, put it in brackets. And then I'm going to take the constants to the other side. So here I'm left with x squared minus 2x. Negative 2 divided by 2 is negative 1, and squared, that's going to be positive 1. I'm going to put that in brackets. And then I'm going to have plus y squared plus 10y. I have 10 divided by 2, which is 5. A squared, that would be 25. Okay. And then I take the constants to the other side. So I had negative 17. If I say negative, so I have negative 2 over 2, that's negative 1 squared, that's positive 1, but it's negative 1 here. If it comes to the other side, it's going to be plus 1. Here I have 10 over 2 divided by 10 divided by 2, which is 5 squared, that's 25, but I have a negative here, so I'm going to add 25. Okay, now I can write x squared here. It can actually be x minus 1, because minus 1 will give me minus 2, and minus 1 times minus 1 will give me positive 1. And then I square it over there. Okay, then here I have y Okay, I'm gonna put a 5 there, right? 5 plus 5 will give me 10, right? And 5 times 5 will give me 25, and that is squared as well. Now on this other side, if I say 26, let's say 25, doesn't matter. 26 minus 17, what will that give me? Well, 9 plus 7 actually gives me 16. So 26 minus 17 will give me 9. All right. And then finally, do you see I have my equation here, which is not at the origin. The center is not at the origin. I have a center actually of, out of interest, I have a center of 1 and minus 5. Okay, remember if we have a positive here, it means we had a negative, negative. Okay, so that is my center. Okay, let's write it out again, because now I need to put the radius in terms of r squared. Okay, so I have y plus 5 squared, and then what if I were to root 9, I would get 3, so that would be 3 squared. So I know that this is my center, okay, and my radius is actually 3. All right, so I hope that was fine, but you will be expected to know this. Okay, now we get to the equation of a tangent to a circle. Okay, so a tangent is a straight line, all right, that is perpendicular to the radius. Okay, so here we have our radius r, all right, and we have a line that touches the circle at that one point. Okay, so this point over here, we know that this line as well as the radius, this line as well as the circle have a similar point over here. I will name it x, y. Again, we have our center. Well, we don't know where it is in the Cartesian plane, but yeah. And then a tangent line, like we said, is a straight line perpendicular to the radius, and hence we have the perpendicular there to show that it's 90 degrees. All right, and you can definitely get the equation of the straight line by you can get it by getting a point as well as a gradient, like we had discussed initially there when doing the revision. So we're going to use a straight line formula for that, because a tangent line is a straight line at the end of the day. So you need a point as well as a gradient to get the equation of that straight line. Now, if you have the gradient of the radius, okay, and now you have just the point xy on this tangent line, and they ask you to get the equation of the tangent line, well, you know that when lines are perpendicular, the gradients, the product of their gradients is equal to -1. So basically, you would have the gradient of the radius, and then you know that the gradient of the tangent, okay, the gradient of the radius, gradient of the tangent, if I multiply that, I'm going to get -1. So that is how you can get the gradient of the tangent line, if you know the gradient of the radius. Okay, and then you just need a point, then you can get the formula, or rather the straight line equation for your tangent line. Alrighty, so now let's do an example. We're actually pretty much almost done with the theory. So now they're saying determine whether the line y is equal to x minus 5 is a tangent to the circle x squared minus 4x plus y squared is equal to 5. Okay, so what would be your process when you're doing this? What would you think about here? If this line is actually tangent to your circle, okay, let's say you have a circle, it must only touch the circle at one place. So if you have a tangent over here, okay, let's pretend that's a tangent. Okay, maybe let me try again. So if you have a tangent over here, it must only touch the circle at that point. If the tangent is somewhere there, that would be your point where it gets into contact with your circle. If there's a tangent over there, same story, it must touch the circle at one point. Okay, if your line cuts the circle, okay, then it's not a tangent anymore. And if you have a line that's just, somewhere far away from the circle, that is also not a tangent. Okay, so what are we going to do exactly? Well, because I know that the tangent and the circle the tangent actually touches the circle at one point, okay, I'm going to make these equations equal to one another. I'm going to solve simultaneously. And what am I hoping for? I'm hoping that when I solve simultaneously, I will have one solution for the x and one solution for the y. That would tell me that this line is tangent to the circle. If I don't have any solutions, it means that the line and the circle are not touching at all. If I have two solutions for x and two solutions for y, it means that I don't have a tangent line. I just have a line that cuts the circles. It's more like a secant line. Okay, so let us do it. So this would be my equation number 1. And then I'm going to substitute, this is equation number 2. I'm going to substitute 1 in 2. Okay, so I have that y is equal to x minus 5. So I'm going to substitute x minus 5 in the place for y. Alright, so x minus 5 squared, and that is equal to 5. Okay, if I solve for x, I will have x squared minus 4x, x squared again, x squared minus 10x plus 25 is equal to 5. I'm going to bring this 5 over to that side. So I'm going to add the 2. So now I have 2x squared. And minus 4 minus 10, that will be minus 14x. And then 5, this side is going to be negative, so I'm going to be left with 20. Okay, now I'm going to divide everything by 2. Okay, so I'm going to have x squared minus 7x plus 10 is equal to 0. Okay, and then I don't want to show the other question. So now I have in my brackets, okay, maybe let me do it on this side. Okay, so therefore I'm gonna have two solutions. Okay, so what will give me 10 when I multiply? 2 times 5 will give me 10. And if I were to add the 2, I would get 7. But in this case, I need negative 7. Okay, so clearly I have x is equal to 2 or x is equal to 5. In this case, I have two solutions for x. And if I have two solutions for x, it means that I don't have a tangent line, okay? I'm not even going to determine the y values because it's clear that this line y is equal to x minus 5 is not touching the circle. It's not tangent to the circle, but it's actually cutting the circle at 2 points, okay? So you can go ahead and determine the y values. You can go ahead and even try to draw this graph. But yeah, you can actually draw this. I'm tempted to draw it. But your center of the circle, for you to get the center of the circle, you're going to have to complete the square for the x side, okay? So that you can get what the x coordinate of the center is. And then also for the y as well. Well, we know that the center is actually on the y-axis, okay? Yeah, and then the straight line over here, we know that it passes negative 5, okay, on the y-axis, and it also passes 5. So if you have 5 over here and you have negative 5, this is how that straight line is going, okay? And the center of the circle, well, we know that it's going to be somewhere. It's going to be somewhere, okay? Maybe, geez, I don't know. If I were to complete the square, now I'm solving it. No, this is for you to do by yourself. You can comment in the comment section here if you actually know how to draw it. And if you can't, I will explain it to you if you ask. All right. Now, we have another question here. Okay, it says, given the circle x squared plus y squared minus 4x plus 10y is equal to 7. So this is the equation of this circle over here. With tangent PQ, okay, touching the circle at point P. If Q has the coordinates 8, 3, determine the length of PQ. Okay, so we can see here, remember the tangent is the tangent line is perpendicular to your radius, okay? And if you were to connect point Q and M, you actually have a right angle triangle PQM, okay, or MPQ, however way. So if I want to get the length of PQ, what I can do, I can work out what the radius is, okay? I can work out what the radius is of the circle, and I can also try to get the coordinates of M. Why would I want to get the coordinates of M? I would want to get the distance between M and Q. We already know the distance formula. And if I don't know what P is, right? If I were to get the radius, then I already have the length of PM. Then I can use Pythagoras to get PQ. Okay, so I think let's start by getting the center. Okay, so we're going to have to complete the square. All right, isn't there a simpler way of doing this? No. Okay, so we have x squared minus 4x, and I'm immediately going to go into, negative 4 over 2, and I'm going to square it, okay, and then minus negative 4 over 2 squared. Then I have y squared plus 10y, okay, plus, I'm going to say plus 5 minus, no, it's not going to be 5, it's going to be 25. Let me just do it the long way. So 10 over 2 squared minus 10 over 2 squared, and that is all equal to 7. All right, so then I'm going to have x squared minus 4x. I have 4 divided by 2, it's going to be negative 2 squared, that's going to be 4. Okay, and then I have y squared plus 10y, and then 10 squared over 2, 10 divided by 2, that's 5 squared, that's going to be 25. Okay, so here we have 7. I feel like we've solved this before. We have 7, and then we're going to subtract. Okay, so it's going to be adding 4, and then I'll be adding 25. Okay, so here I have x minus 2 squared plus y plus 5 squared, and that is equal to, okay, 7 plus 4 is 11, 11 plus 25, that is 36. Therefore, the equation of my circle, x minus 2 plus y plus 5 squared, and that is equal to 6 squared. So firstly, I know my radius. My radius is 6, okay? So therefore, what I can say is PM is equal to 6 units, okay? And then I know that M, the center of the circle, I have 2, and I have negative 5. And you can see it's in the fourth quadrant where y is negative, but x is positive. Okay, so great. I have PM. Now I can get PQ. No, I can get MQ now. Okay, so the distance of MQ, or QM, I think I like QM. So QM will be the x-coordinate of Q, which is 8, minus the x-coordinate of M, which is 2, and I square it. The y-coordinate of Q is 3, and the y-coordinate of M is minus 5, so minus minus gives me a plus, and I square it, and all of this is under the square root. Okay, so 8 minus 2 is 6, 6 squared is 36, and then 3 plus 5 is 8, 8 squared is 64. Okay, so root 36 plus 64 is equal to 100, so QM is actually, root of 100 is 10. Okay, so I have 10 units for QM. So I have QM, I have PM, now I can get PQ. So how do I get PQ using Pythagoras? I will say that QM, since that is the hypotenuse, is actually equal to PQ squared plus PM squared. Okay, so yeah, I want PQ. So PQ will actually be equal to QM minus PM. Okay, what is QM? QM is 10 squared. Okay, yes. QM squared is equal to 10 squared. All right, and I'm going to subtract PM squared, which is 6 squared. And all of that. So therefore, what is PQ? Okay, so 10 squared is 100. 6 squared is 36. So 100 minus 36 is 64. Okay, so it's 8 units. So 64 squared, rooted. So if I take 64, that's rooted. Okay, so it's basically going to be 64 in here because 100 minus 36 is 64. Therefore, PQ is 8 units. Okay, and yes, we have found the length of PQ. Okay, that is how you would solve that. I gave myself little space, now I'm squeezing everything in. Okay, now we get to theory that I don't really think, I haven't come across it being discussed at length when it comes to textbooks, but I've seen questions being asked, so I think they want you guys to actually think about it. But yeah, I've written out what you can expect, okay, so that whenever they ask such questions, you don't have to think about it too much, you know what to do, and you save time, okay, because we know sometimes it's difficult to finish the paper, especially paper 2. Now, what do you do when circles are touching internally and externally, or externally, okay? So two circles will touch if the distance between their centers, which is D, is equal to the sum of their radii, or the difference between their radii. So if they touch externally, okay, we see here they touch externally, this would be circle 1, and that is circle 2. And they are touching externally. So what you would do, you would get the radius of 1, okay, which is from the center to the circumference. Then you get radius 2, again from the center to the circumference. And then the sum of their radii is actually equal to D, okay, and we defined what D is. D is the distance between the centers. So if they're touching externally, you would know that the distance between their centers is the sum of their radii. Now, if they were touching internally and you were supposed to get D, the distance between their centers, okay, again, you would take the radius of circle 1 and the radius of circle 2. But now you can see here that actually it's going to be the difference because you have R1, which is quite large there, and you have R2 there. And the distance D, distance between their centers, would be the difference between their radii. Okay, you're going to take the bigger radius and subtract the smaller radius, and you're going to get the difference, the distance between their centers, okay, which is D. So now let us do an example. Here, they're saying, show that the circle x plus 3 squared plus y minus 4 squared. So already you know that the center there is minus 3 and 4. Okay, and the radius is 2. So show that the circle touches this other circle, x squared plus y squared is equal to 9. So this circle here is at the center, at the origin. Okay, so the origin, and it has a radius of 3. Okay, how are you going to show that the circles are actually touching? Okay, like we said, they can either touch externally or they can touch internally. Or before we even go further, they can cross each other. They can actually intersect each other. So if you want to show that the circles are touching, you can prove that they are not intersecting, okay? Or you can show that they're actually touching, meaning you get the radii, okay, either the sum of the radii or the difference between the radii, and or you can show that they're not intersecting. And what would happen if circles are intersecting? Okay, let's do this before we answer the question. So basically, if circles are intersecting, two circles will intersect at 2 points. Okay, so we have these 2 points over here, 1 and 2. If you get the difference between the radii is smaller than D, which is smaller than the sum of their radii. Okay, That's intersection of circles. And you also have another type of intersection of circles. Well, basically, if the center of one circle will lie on the other circle. Okay, so you have your big circle here, and it's actually lying on the center of the small circle. I'm going to say circle 2. Okay, so we can see that there, in this case, D will be equal to R1. But in this case, where you have the smaller circle now touching the big circle's center, you would have that D is equal to R2. Okay, so that is what happens if circles intersect. So now let's get back to this question. How can we show that the circle x plus 3 squared, y minus 4 squared is equal to 4, that it touches that particular circle? So because when it comes to circles that are touching, there are only 2 of them that I can consider. Okay, I can assume for one that, okay, maybe they are touching externally, but we'll see. I won't consider the fact of proving that they're not intersecting, because here I have like 3 types of intersections. So let's just go with them touching. So what I'm going to do, I'm going to get, okay, so if they are touching externally, here's what I'm going to do. Okay. Another long way of doing it is actually sketching these circles. And then, yeah, I think before I actually sketch them, let me just get the center. So the center for the circle, let me use a different color. Center of the circle here is actually minus 3 and 4. And the radius is 2. Okay, on this circle here, I have that my center is at the origin, okay, and my radius is 3. So if I were to sketch it quickly, please, without wasting much time. So this would be this first circle over here, and then the second circle, I have a center at minus 3. So if this is 3, okay, so I have a circle at minus 3 as well as 4. So maybe that's 3. So the center is somewhere here, and it has a radius of 2. So probably this is me assuming that they touch like that. Okay, so I have the center there, and I have a center here. Okay, so what I'm going to firstly do, I can see that they're touching externally. Okay, just by sketching it quickly, so I don't have to consider they're internally touching. So I'm going to get the distance between these circles, between the centers of the circle, by using the distance formula. After getting the distance between them, I'm actually gonna, remember we said that if they touch externally, we're gonna take the sum of their radii. I know that the sum of their radiuses, or radii, so I know that the sum of the radii is actually equal to 2 plus 3, which is 5. So I'm going to have to prove that D as well, the distance between their centers, is actually 5. Okay, so I'm going to say the distance between, I'm going to call this circle 1 and this is circle 2. Distance between circle 1 and 2, the x-coordinate of 1 is negative 3. I'm going to subtract 0. Okay, the y-coordinate of 1 is 4. Okay, gonna subtract that. All that is under the square root. So I have 3 squared, which is 9. 4 squared, 16. 9 plus 16 is 25. The root of 25 is 5. Okay, so I have actually that the distance between their centers is actually 5 units. And the sum of their radii is 5 units as well. Therefore, the circles touch. Okay, I would go as far as saying they are touching externally. Okay, so yeah, I think a trick here, so that you don't waste time, if they've given you both the equations of the circle, just try to sketch it quick, so that you can see are they actually touching externally or actually touching internally. Once you've determined that they actually touch externally or internally, then you can go and use the appropriate equation and not waste time. Okay, and yeah, and if they're not touching at all, then you would find that the distance between their centers actually lies between the difference of the radii as well as the sum of the radii as we have it here. Okay, but this other extra information really is exactly that. Extra information just in case they ask you. Okay, yeah. And then lastly, with regard to theory, we also have concentric circles. Okay, what are concentric circles? So we see here that concentric circles are two circles which share the same center, if I could say. So they both have the same center. Okay, so circle number one, it has a bigger radius, but the same center. So if you have their center x, y, also circle 2 has the same center but a different radius. So two circles are concentric when d is equal to 0. Remember, d is the distance between the centers of the circle. So obviously, if the center is the same, d is going to be 0. So just be careful about that. If they ask if circles are concentric, they're referring to this. They have the same center. Okay, meaning their d distance between the centers is 0. Okay, and now we're gonna have a look at a question from the exam paper. All right, so I found a paper. It's from 2016, February, March, supplementary paper that was written. So question 4, okay? You can already see in the diagram below, the equation of the circle with center O is x squared plus y squared is equal to 20. Okay, so I already know that my center is at the origin, and also my radius is actually root 20. Okay, the tangent PRS, okay, to the circle at R has an equation y is equal to half x plus k. PRS cuts the y-axis at T and the x-axis at S. All right, so now it says determine, giving reasons, the equation of OR in the form y is equal to mx plus c. So the equation of OR, we know that the radius is perpendicular to the tangent, right? We've said that quite a lot of times. So OR is actually the radius. I can already see that the gradient is negative because we are going down from left to right. All right, and then, okay, if I want to get the equation of a straight line, I've been telling you guys to get the equation of a straight line. Well, basically, I need a point and I need the gradient. Okay, what point do I have? I know that OR passes through the origin, right? So I have a point of 0 and 0, but what is my gradient? And my gradient, by the way, has to be negative. So because I know that OR is perpendicular to PRS, I know that the gradient of OR multiplied by the gradient of PRS, I'm just going to say PS, it has to be negative 1. Okay, and do I have the gradient of PS? Yes, I do, because they told me that the equation is y is equal to half x plus k. That half, that is the gradient that I'm looking for. So basically, the gradient of OR times a half will give me negative 1, and therefore that gradient will be negative 2. I told you it has to be negative because it's going down. Okay, it's decreasing from left to right. So I have a point, I have a gradient, we can get the C, we can get C, okay? So y is equal to mx plus c. What is the y coordinate? 0. The x coordinate is going to be 0. My gradient is negative 2 plus c, so c is going to be 0. I actually shouldn't have solved that because I can see where is this line crossing the y-axis. It's crossing it at the origin, which is 0. So yeah, but basically I've taken up time. But basically the equation then of OR, so y is going to be equal to negative 2x because c is 0. Okay, so that is the equation. And they said determine giving reasons. Okay, we got the gradient. Well, you can explain that in words, guys. All right, and then 4.2. It says determine the coordinates of R. Okay, so R, it is actually R, yeah, many things are happening there. You have an intersection of OR and PRS. Okay, if we only knew what the value of K is, we could make those two equations equal to one another and then solve to get R. But we don't know the value of K yet. Okay, another thing, you have OR that is also, so at R, you have the line OR that touches R, and you also have the equation of the circle that touches there at R. So what I can do, because I have the equation of the circle, I can make this straight line OR. Okay, so my first equation here, I would say y is equal to negative 2x. That's my first equation. And my second equation, I have that x squared plus y squared is equal to 20. That is my second equation. So then I'll take my y and plug it into my second equation, and then I'll solve for r. So we'll see when we solve what the answer will give us. So I have there x squared plus, remember y is now negative 2x, and we square it, that's equal to 20. And then I have x squared plus 4x squared. Should I bring in this negative this side? Maybe let me leave it there. So I have 5x squared is equal to 20. If I say 20 divided by 5, I will have 4. Okay, therefore x is equal to plus or minus 2. Okay, yes, it makes sense. So, but what would r be? Remember, they want the coordinates of r, not just the x value of r. So this r is on the positive side. Okay, so I'm going to take away this negative. Okay, let me rather put it like this. Because we are looking for r, we're gonna say r is equal to negative 2. Sorry, x is equal to negative 2 or x is equal to 2. But because we're looking for r, it will not be negative 2. It will be 2 only. Then I'm going to take my equation 1. So we're going to substitute x into 1. Okay, so we have y is equal to negative 2. You can use equation 2, but it's just so long. This one is simplified. Okay, so if I substitute 2 there, I'm going to get that y is negative 4. And it makes sense because r is in the fourth quadrant, so y should be negative. So therefore, r would be 2 and negative 4. Okay, so we're done with 4.2. Now 4.3. Determine the area of triangle OTS. So this is where O is, this is where T is, and that's S. Okay, and we can see that it is a right angle triangle. So if we want to get the area, oh, they say given that R is 2 and minus 4. Okay, if it is given that r is 2 and minus 4, how are we helped? Okay, here's what I'm thinking of doing. I'm thinking of solving what k is. Okay, remember, to get the equation of a straight line, you need a gradient and you also need a point. I already have the gradient, so I'm going to substitute point r into the equation. Okay, so I have the equation y is equal to half x plus k. In substituting the points of r, I'm going to determine what k is. And how does that help me? Once I have k, I can then determine what t is, because that's the y-intercept of this equation. And I can also determine what s is, which is the x-coordinate. And in getting the x-coordinate of s, or the x-intercept, I can basically get the distance of OS. And by having the y-intercept, I can get the distance of OT. Okay? And therefore, I can use Pythagoras to get TS. And then finally, I don't actually need TS because the area of a triangle is half base times height. I already have my base, which is OS. I would already have my height, which is OT. Okay, so that is the plan. So let us substitute R, the negative 4, Y is negative 4, and then X is 2. And that's K. So K would be equal to negative 4, negative 1, because a half times 2 is 1. So K is negative 5, which makes sense because K is the y-intercept, right? Okay, if r has a coordinate of -4, you're expecting t to have a smaller value than -4, which is -5. Okay, so therefore t would be 0, -5. Okay, and now we can get what s is. So if I have y is equal to half x minus 5, okay, in getting the x-intercept, I'm going to have y being equal to 0. So I have half x is equal to half x minus 5. Yes, so I would then say half x is equal to 5. X has to be a positive because we can see that s there is on the positive side of the x. X line. So now, if I were to say 5 divided by a half, that would be 10, okay? And that makes sense. I mean, S is quite far. If you were to compare OT, you're expecting OS to be bigger than 5 units, right? Okay, so X is equal to 10. Therefore, S is 10 and 0. So now I can get the distance of OS, that would be 10 units. And the distance of OT would be 5 units. Remember, distance cannot be negative. Okay, so yes. And then now, the area of triangle OTS is actually equal to half base, and the base is OS, times height, which is OT. Okay, and that will be half. OS is 10 and OT is 5. So 10 times 5, that is 50, times a half, that would be 25 units. But because it is area, it has to be units squared. Okay, so 4.3, now we get to 4.4. Calculate the length of VT. Okay, so we have this big triangle over here. Okay, which is triangle VR and T. Okay, and that angle is actually a right angle triangle. Okay, just take that back. Okay, so if we look at that triangle there, if I were to redraw it here, what do we know? That is V, that is R, okay, and that is T. We know that the radius is actually root R, right? Remember, R squared is equal to 20, so therefore R would be root 20. And I know that VR is actually the diameter, okay? So therefore the diameter is twice the radius. So I know that VR is actually twice of root 20. And then do I know TR? Well, I know the coordinates of R are 2 and -4. Okay, the coordinates of T are 0 and -5. Okay, so I'm going to have to use the distance formula to get the distance between, or the distance of R and T. Okay, and then I'm going to use finally Pythagoras, because VT is the hypotenuse, so I'm going to use Pythagoras to get what VT is. Okay, so let's get what RT is. Okay, so if we're going to get the distance RT or TR, doesn't matter. So we're going to get the coordinate, x coordinate of R, which is 2, minus the x coordinate of T, which is 0. And then the y coordinate of Y, which is -4, minus the y coordinate of T. Okay, that's actually negative. Let me just put that properly. Okay, 0, -5. So that's more clear. So minus 5 is going to be plus, and that's squared. All right, and then we have 2 squared, which is 4, and then minus 4 plus 5 is 1, so 1 squared is just 1, and then we have root 5 for RT. I'm just going to leave it in surd form. So we have RT, there's root 5. We can now get VT. Okay, so I made a discovery there. So if you have a look at V, let me just comment there with a different color. So yeah, if you have a look at R, okay, I don't know how to take away this comment thing, but have a look at R, you have 2 and minus 4. Okay, R and V are actually symmetric about the line y is equal to x. Yeah, they are symmetric. Okay, so let me see. Yeah, they are symmetric about that line. But when we want to get the coordinates of V, okay, you're going to actually get over here. So if this is 2, okay, this is 2 and that's minus 4. V as well, that will be 4, positive 4, and that will be negative 2. Okay, yeah, so actually, if R, you have x, y, so V, you're going to have negative x and y. Yeah, so yes, and that is why we have minus 2 and 4 over there. So basically, I could have just used the coordinates of V and the coordinate of T using the distance formula to get this instead of, going the long way, the longer route. But anyway, this is where we are. Let's just continue. So VT squared is actually equal to VR squared plus TR squared. And what is VR? Is actually 2 root 20. Okay, and then we have TR, which is root 5 squared. Okay, so if we square that, we're going to get 4, and then this square root to the power 2, that's going to cancel out, so we're going to be left with 20. And here we're going to have the square root and the power 2 actually canceling each other out, so we're going to have 5. So actually we're going to have 85 over there, and VT will actually be root 85. Okay, and if we check on the calculator what root 85 is, because they didn't tell us to leave it in surd form, that's actually going to be 9.22 units. 9.22 units. Okay, otherwise, another way of solving VT, like I said there, you could have used the distance formula. Okay, and you would have said the x coordinate of V is minus 2, the x coordinate of R is 2. No, x coordinate of T. What am I saying? So x coordinate of V is minus 2, the one of T is 0. Okay, the y coordinate is 4, and that of T is minus 5, so that would be plus 5. So we're squaring it there. So basically we're going to have 4 this side, plus 4 plus 5 is 9. So 9 squared, that is 81. And therefore 4 plus 81, that would be 85. So again, it's the same. It's much simpler than what I did previously. But whatever you understood better, that's all that matters, as long as you get those marks. So guys, that is the end of the lesson. I hope that you have a good day further. Please don't forget to like our videos and subscribe to our channel. While you're at it, click on the notification bell so that you are notified when we have more videos that we upload.